So hello, today we want to look at binomial expansion. Okay, so in our last class we dealt with the Pascal triangle. Let's see how that turns out. We have AB raised to the power 1, that's the coefficients. We are considering the coefficients now. Okay, so A plus B raised to the power 2, it's gonna be, add this, that will be 2, guide it with 1. A plus B raised to the power 3, so that will be 3, 3, 1, 1. So you know what we're doing? We're adding this together, add this together, we guide this 1, 1. Right? That's what we're doing. Okay? Now if we say A plus B raised to the power 4, so that was 4. Add this, that was 6. Add this, that was 4. We guide it 1, 1. Right? So do you know that this expansion can be carried out using combination? So combination is arrangement or selection. That is when you are doing selection from a set of objects or a set of items that you want to select from. Okay. So now this particular combination, we call it n combination R. Hmm? So that is we are selecting R objects from n objects, right? Or R numbers from n numbers. Okay, so the formula is n factorial all over n minus r factorial all over r factorial. So what is all this factorial? When we say 2 factorial, it means 2 times 1. That's just what it means. So when we say 3 factorial, it means 3 times 2 times 1. That is, we will be decreasing while multiplying the numbers. We're decreasing the number by 1 and we'll continue to do the multiplication up to 1. So when we say 4 factorial, so that is 4 times 3 times 2 times 1. Right? So when we say n factorial, it's same thing as n minus 1, n minus 2. So it continues like that up to 3 times 2 times 1. It continues to decrease like up to 1. You see that? Okay, so when we see something like this, so these are numbers. These values you're seeing, they are numbers. There's also another formula that says n combination r is same thing as n combination n minus r. So these two formulas, they are applicable to combination, right? Okay, so now we want to represent this with combination, right? Okay, so a plus b raised to power 4. We'll see whether we'll get the same thing. So this can be represented as n combination 0, right? Then it's going to be n combination 1, that is 4 combination 0, 4 combination 1, 4 combination 2, 4 combination 3, 4 combination 4. You see? So if we find this one can easily be found using this formula. Or if you like, it can also simply be found using a calculator. You can as well use our calculator to find this. So let me show you how to do that. Okay, so this is the combination. You can see on top of the division sign that is NCR. That is N combination R. Now we want to look for 4 combinations 0. So that's going to be 4. You press shifts, then you press this. Any of the brown values. If you want to access it, you have to click on shifts. So 4 combinations 0. So that will be there. So you have 1. You see that? 4 combinations 0 is 1. 4 combination 1. So this is going to be 4 shifts combination 1. So that's going to be 4. You see, this is 4. Okay, 4 combination 2, 4 combination 2, so that will be 6. So this is 6. Now 4 combination 3, 4 combination 3. You see, so this is going to be 4. And 4 combination 4, 4 combination 4. You see, that's 1, right? So this is 1. So what do we observe? We see that this value is same as this value here, right? So it shows that we can easily represent this coefficient, instead of using Pascal triangle. For instance, we want to find n to be perhaps 20 or 40 or whatever number, so we'll continue to use Pascal triangle up to 40? No. Instead of doing that, we can just simply use the combination to do that. So which tells us that if we have a plus b raised to power 5, so it's going to be what? N combination, the coefficient are the ones we're looking for right now. N combination 0, and that's 5 combination 0, 5 combination 1, 5 combination 2, 5 combination 3, 5 combination 4, 5 combination 5. You see? And we're also using this formula as well. We know that when this one is 5 combination 0, to be the same thing as 5 combination 1. And 5 combination 0 is 1. 5 combination 5 is 1. Okay? Even if you apply that to using this formula, you're still going to get the same thing. 5 combination 1 is 5. Like we have seen earlier, when we did 4 combination 1 is 4. And 4 combination 3 is also 4. You see? So using this formula. Okay? So this particular formula shows that we can use this combination to represent the coefficients. Right? Okay? So if we now want to get the general expansion, that is the general expansion of a plus b raised to power n, that was a plus b raised to power n. So that was n combination 0. That's the first coefficient. That's a raised to power n minus 0. That is n minus 0, which is of course a raised to power n, right? N minus 0. Now b raised to power 0, right? B raised to power 0. B, we have this power. Now the second question with n combination 1, and that was a raised to power n minus 1, b raised to power 1. Are we good to go? Now, so n combination 2, that will be a raised to power n minus 2, b raised to power 2. Do we see that? Okay. The next, let's say we are going to the second to the last value. So that will be n combination n minus 1. That will be a raised to power n minus 1. And that was 1, right? That will be 1. Now b raised to power n minus 1, right? Then the last term is going to be n combination n, which is a raised to power 0. Now b raised to power n. So that will be the last term. So this is the general expansion. Okay. So these values in in some textbooks or whatever, you will see that instead of writing these ones in this format, they write it using this. Okay, which is the same thing, right? Okay, so this is the general expansion of binomial. Okay, thank you.